Hi everyone, we're going to continue on with our animal kingdom, different phylums within that category. So the phylum that we're going to start with today is phylum Annelida. So these are going to be segmented worms, so they have complex organ systems like a heart and an excretory system. So excretory system is taking things out of the body, so either urine or fecal matter in this case. And then most of the examples that we'd be familiar with would be earthworms or leeches, but the ones in the ocean that we're going to be talking about are going to be those bristle worms and tube worms. So tube worms should sound familiar. We did talk about these slightly when we were going over the hydrothermal vents. That is where these types of worms are going to live. So they fall into this phylum of Annelida. Because they have complex organ systems like a heart and an excretory system, and they're also considered segmented worms. So let's take a look at these. So since we are familiar with the tube worms, I figured seeing these bristle worms would be more effective here. So again, bristle worms, named kind of for their appearance. Again, we can see some of these little bristle-like protrusions coming off here. Same here with this worm. But remember, our defining characteristics here are going to be the excretory system, which we can kind of see here in this transparent worm. And then we have a little bit more organ systems, including the heart here. So the next phylum that we're going to be talking about is Arthropoda. So defining characteristics here are going to be segmented bodies, jointed legs, and an exoskeleton. So this is the first time that we've seen this word here, exoskeleton. So we're going to start seeing that these animals that we're talking about are going to start becoming more and more familiar to what we might be used to. So exoskeleton means they have their skeleton on the outside. So a lot of what we're going to see here are crustaceans for the ocean, and then insects would also fall into the Arthropoda phylum. So specifically here, barnacles, crabs, lobsters, and shrimp are going to fall into this. They have segmented bodies, those jointed legs, and an exoskeleton. So again, we can see here's our segmented bodies. We can see here a separation of the body and the tail, these jointed legs that allow them to move on the surface, same here with the shrimp and crab. Barnacles you might not think have that type of body system because you're used to seeing them in their cemented form. So barnacles here, they do cement themselves to surfaces like whales, boats, or even rocks. But the animal inside is actually the important part. So each one of these barnacles have an animal within this little cemented cavity here. And then our last phylum that we're going to talk about is Anthraderma. And some defining characteristics here is going to be radial symmetry. So that means if we cut these guys in half in pretty much any direction, they're going to be symmetrical on both sides. So body is going to be divided into 5 to 12 parts here, and they have these really tiny little tube feet that help them move along the surface or the bottom of the ocean. So if we take a really close-up look here, this is going to seem very familiar to sea stars or starfish that we're pretty familiar with here. So again, defining characteristics for this phylum is going to be that radial symmetry, cut it in any direction and it will be symmetrical on both sides, divided into 5 to 12 parts, and those tiny little tube feet that are going to help them move. So if we take a look here at our examples, it is going to be our sea stars, our sea urchins. So again, this is probably the most common sea star that you're familiar to seeing. But again, if we take a look and we cut it down here, it's going to be symmetrical on both sides. Cut it down this one, symmetrical on both sides. And same all the way around. Same thing is going to happen here for our sea stars that have multiple legs. And even our funky looking sea stars here. But our sea urchins, you might think in their open form, which is usually what we're used to seeing them in, they're not very symmetrical or they can't perfectly be cut with that radial symmetry. But when we see them closed, like here, we can see that each row of 2 dots is a division of our sea star. So we can cut here, 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 all the way around, and that is going to be where we see that radial symmetry. And they do have those little tiny tube feet as well to help them move along the ocean floor. So that is where we're going to stop for today. If you have any questions, please let me know.